Welcome everyone to the 2024 CIP Competitiveness Improvement Project CIP informational workshop offered by NREL, your National Renewable Energy Laboratory. And here we're giving our annual workshop here in the fall because NREL has put out a notice of intent to release a solicitation for proposals for CIP round 2025. So this is part of gearing up for that. NREL's distributed wind energy platform lead, Ian Baringould, is going to kick us off today. So please help me welcome Ian. Thank you.
Thanks, Brent. Hi, everybody, and thanks for being here. Typically, Brett Barker and Patrick Gilman from DOE would also join us, but due to some family stuff, neither of them were able to make this part of the call. Hope that they will be able to join a little bit later, and certainly for the Q&A session at the end when we're trying to get some feedback. But they send their regards. So I'm going to give a quick overview of CIP, and then we'll get into the meat of what we're doing. Brent, do you want to go to the next slide? So first off, Ian Baringould with the National Renewable Energy Laboratory. I lead the portfolio of work here under the Distributed Wind Energy Program under the Department of Energy. We also have lots of collaboration across the DOE lab network with Pacific Northwest National Laboratories, Idaho National Laboratories, and Sandia. And so even though NREL is here and we're talking about the kind of the tech support and this program that is run out of NREL, it is a DOE program and therefore leans on the larger team here within the National Lab complex. Quick land acknowledgement: NREL is on the historical lands of the Ute, Arapaho, and Cheyennes people. I get to look out my window and see over their land. It's beautiful here, so acknowledge that. Because we don't have time to do a whole around the room, what we do part of this is a little bit about collaboration, and so love everybody to pop into the chat and at least put your name, your company, some information there, because this will be shared broadly to folks that are on the call. And so it allows folks to get a little bit of a better understanding of who's here and who they might want to talk to, not during the sessions today, but follow up with. So please don't hesitate to do that to get a little bit more of this community network going. Next slide. So here's a quick overview of the sessions that we have. And this is really designed around providing kind of information to people who might not know as much about the Competitiveness Improvement Project, but then also do a quick reminder or touch base with some of you that have lots of experience with CIP. So brief introduction, Brent will do a more detailed overview of CIP. We'll talk about the different topic areas that we have done. And then looking at certification and a little bit deep dive into the whole certification regime for wind and how we relate around certification through the CIP project. Tomorrow, we'll come back, talk about the kind of the listing efforts, certification in a little bit more detail, design reviews and how we engage around that process, procurement, some additional considerations, and then at the end of the day tomorrow, some discussion specifically around where we try to get feedback from you around CIP. As the folks who have been part of CIP in the past know, the whole goal of CIP is to engage with industry and provide the distributed wind industry with pathways to commercial technology. And so if there are things that we're offering here or need to offer, if there's assistance that we need, that we, DOE and the laboratory complex, need to be providing from a technology development perspective to you, the companies, we're all ears. So we want to know how we can do this better. So the whole goal of the Competitiveness Improvement Project is to get more turbines, certified turbines on the market in the United States. And so anything that we can do to help support that, we might not be able to do it, but we need to hear from you so that we can look into doing that. And we'll talk about some of that during this discussion session tomorrow afternoon, but encourage feedback then or feedback at any point in time. We can only make this better if we hear from you on how to do that. We will have breaks for Q&A. And then lastly, we do have office hours set up for tomorrow to talk about kind of specific questions or technology specific things. We'll be pretty generic over the next couple of days here, but we understand that we want time, you want time to talk about your technology. And so don't do that in this open forum. We don't have a lot of time. Keep your Q&A to kind of things that would be applicable to any company that's on the call. And if you have specific questions or want a specific discussion around your technology, email Brent here and we'll set up a time to dive into those. We are available to you to engage around these things. So we don't want to push you off. We want to talk to you. We just want to make the best use of this time with the 30 plus people we have on the call. Next slide. So as Brent mentioned at the top, a special notice went out in mid-November saying that NREL plans to release an RFP for CIP early in 2025, and there's a link. If you also Google NREL CIP or NREL Competitiveness Improvement Project, you'll get our website and you'll see there's a link there to this notice of intent. You can also go again onto the NREL website and find links to previous solicitations for CIP. So if the notice intent is there, you can read through that. But if you're interested in what we've produced in previous years, you can also find that there. And that's really insightful to look back at what's happened in the past. Next slide. All right, a little housekeeping rules here. First off, any information covered today and tomorrow are relative to past CIPs and should not be assumed to be consistent with any potential future offerings, or even if there will be a future offering. We put out a notice of intent saying we plan to do this. So we have all intent to do it, but until it happens, no guarantees there. And again, we want feedback from you. So what may be put out there in CIP 2025 hasn't even been defined yet. That's why we're talking to you all right now. And so we can't comment on something that's going to happen in the future. Can't do it. But we're doing our best to inform you about how things have operated in the past, and we'll be consistent about doing that. Again, second bullet, we can't talk about what's going to happen in the future. We can talk about what's happened in the past. If a call for proposals is released, NREL and DO staff that are supporting the solicitation will not be able to hold discussions around CIP proposals. So again, this goes back to, if you want to talk to us, now is the time to talk to us. If you have ideas about a solicitation that you want to do, but you're not sure, now's the time to talk to us. Not just on office hours on Friday, just reach out to Brent, reach out to Brett Barker, reach out to myself, but Brent is the lead of this project. So reach out to him and we'll have a dialogue with you. Once the request for proposals has been publicly released, we cannot talk to you. And so do it soon, and we're happy to have that dialogue. Once the solicitation is released, there will be a formal process to answer questions, and that'll be noticed in the release. So it's not like you can't ask questions. We just can't have a real upfront dialogue with anybody, because that would be unfair. If you're interested in being placed on the list, Kendall Jackson is our contracting person, and so we encourage you to email her and she will put you on the list. We also have the website here, and we'll talk a little bit later about a LinkedIn site. So we really try to push information out when the CIP is released, if it is released. But certainly getting on Kendall's list is the best way to be informed of any changes within the process. Next slide. So more housekeeping rules. Keep yourself muted. We've all been doing this for way too many years now, so hopefully that's fine. Please post your questions in the chat or raise your hand. If it's something really critical to the point, go ahead, but because the people who are talking might not be able to see the screen, we'll try to flag that and at least address it in the Q&A. Happy to answer questions and unmute people. We don't have a large group here, so much rather hear you than type it in, but feel free to type it in. When you ask questions, please introduce yourself and ask the questions. Again, be to the point. We don't have tons of time, and keep it to things that are generic. If you want to talk about your own technology, happy to do that. We'd love to talk to you about it, but let's do it in a more private thing. Protect your IP as well as be respectful of other people's time. And then again, lastly, as I've talked about, we're all happy to answer questions, but it should not be considered defined guidance on any potential solicitation. I think I've probably beaten that one to death. Okay, next slide. So just a couple of announcements. We've got the DWEA 2025 conference coming up. And so you can go to distributedwind.org. The DWEA organization is a great colleague and collaborator with us. So encourage people to attend that event. And you'll also get the opportunity to meet with a bunch of companies that have worked with CIP before, as well as it's a great networking event. And we try to time the solicitations to allow companies to engage with each other about potential CIP applications, assuming that there is a request for proposal around the Distributed Wind Conference so that people can engage around it. Again, no guarantees about when the solicitation is released. I don't even know myself. So so don't make any assumptions based on the last couple of years. It may be different. Next slide. And then, as I mentioned, we do have a LinkedIn group. And so that is a great place to get information about CIP. We'll update the LinkedIn group when announcements are made or anything of that nature. But more importantly, LinkedIn is an opportunity for all of you to collaborate around the kind of services you could provide. If you're a turbine manufacturer and are looking for someone to help you with the certification process or things like that, encourage you to use LinkedIn to build those connections. When we did this in person, it was great because we would have coffee breaks and people could chat and things like that. We're not in that space anymore. So we're looking for opportunities like LinkedIn to allow people to collaborate because you need help in the proposals that you're developing, and LinkedIn is a great way to connect around those, as is the DWEA conference. Next slide. And I think that one's it, right? Yes.
Yeah.
So happy to answer any questions.
I just want to go back to this in the chat. We were saying name, pronouns, company, and anything else helpful, like your company website, LinkedIn, contact information, where a short sentence of your interest here.
Yep.
Good. Sorry. Thank you again.
Oh, no. Thank you. Thank you, Brent. Any questions at this point in time? If not, we can move on to Brent giving a broader introduction to the Competitiveness Improvement Project.
Great. Well, thank you, Ian, and thanks everyone for joining today. Heather says that the block of rooms for Distributed Wind 2024 conference or 2025 is filling up. So register and book your room soon. I guess I need to do that. Okay, great. Well, just want to give an overview of our competitiveness improvement project. I'm Brent Somerville, so I am the relatively new project lead for CIP. It's been around for a while. Others have led it, including Ian, but Ian's around, as you see, as a senior advisor and helping us keep it moving here at NREL. So we're trying to address a challenge, and have been for a while. The U.S. distributed wind energy market has a great opportunity for deployment across the country. Lots of viable windy land with good economics. But the industry has required continuous and rapid innovation to stay competitive with other distributed energy resources or technologies. And these companies are almost exclusively small U.S. businesses that have limited resources and trying to make it go with their wind turbine products in this industry. So through CIP, with support from Department of Energy Wind Energy Technologies Office, NREL has been administering this, offering competitive, cost-shared subcontracts to manufacturers of small and medium wind turbine technology. It's a little broader than just turbines because we've got blades, towers, generators, inverters, and other power electronics that play a part in the industry. We're working with industry on these technology partnerships to develop, optimize their designs, advancing ultimately to certification or listing of their products so that they can be commercialized and on the market and seen as an option for folks looking to deploy various ranges of distributed wind turbines. So some of the things we help these partnerships help fund projects that reduce costs. It's LCOE from the beginning of CIP has always been a thrust. It's to be competitive, become competitive, remain competitive. Um, we also support product innovation. Incremental improvement has been a really um, underlying principle of the wind industry, taking something, making it cost less, making it more reliable, making it more productive, optimizing a component or optimizing the whole system for a variety of distributed applications. And really ensuring that the distributed wind energy consumers have wind technology options that have been field tested and third party assessed and are certified for performance and quality. Of course, manufacturing is a big part of this. These are U.S. companies. We've been a leader in distributed wind for a while, so we fund projects to advance manufacturing processes to further reduce hardware costs and keep up with growing demand for the technology. Ultimately, we're doing all this to help the OEMs, the manufacturers, advance their technology into certification and onto the market and expand access to distributed wind technology across a range of sizes for a variety of applications. I would say this CIP is a pretty unique DOE funded program in that it's been around since 2012. I would say most lab projects are shorter in duration, but it's been so successful that it's still around. So since 2012, 77 awards have been issued to 30 U.S. distributed wind companies across 22 states, which represents about $18.5 million in DOE investment out the door, leveraging over $11 million in cost share from the companies. And we manage the projects through a defined period of performance through a subcontract. So there is some subcontracting involved to the awardees. We also, as the administrators of CIP, provide oversight and technical assistance to help keep moving these projects along. The continued support is evident through the timeline here. Back in 2012, we had 2 awards with 300K going out the door. The number of awards increases fairly steady over the years. We've added more and more topic areas to address industry needs. And 2024, the last round, we were able to fund 13 projects with $3.2 million going out the door, total project amount of $6.5 million, including cost share. So it's a competitive solicitation. So the request for a proposal, it has a details on the merit criteria that you should respond to in your proposal, and a statement of work for the tasks and deliverables associated with each topic area. And there are cost share requirements, typically 20% and sometimes 50%, which we'll go over. The periods of performance are try to keep short, normally about a 21-month period of performance for the subcontract to make sure the projects are manageable and can be completed in a timely manner. CIP topic areas are generally focused on higher technology readiness level efforts, ranging from a prototype design that's had considerable development but needs a little more, all the way through testing, certification, and commercialization of the technology. We are, you know, we are focused on distributed wind technology, but we try to maintain a very open approach to what the industry needs. So technology, configuration, component, and application neutral, but we do cap it at 1 megawatt or 1,000 kilowatts of rated power. So we're trying to serve the needs of these small and mid-scale turbines that are exclusively used in distributed applications, and target our funding and technology partnerships to that sector of the industry. As you can see, we haven't had a round every year, but we haven't taken many years off. 2016 and 2023 were the only two gaps to do support existing contracts and do other rehauling of the program. But a sustained solicitation process allows technologies to move from their initial prototype innovative concept up through testing, certification, and commercialization. So you don't have to go through every piece in a serial manner of CIP. We try to fund projects where you are. Maybe you come in and just get an award to certify your technology and off you go. Maybe we see you coming back for several steps of your development process. But the annual solicitation is an effort to keep things going. We do work with awardees to modify or end contracts if it is determined that the original scope is not achievable. We know things change, and so we'll see later we're able to absorb some minor changes and modify contracts. But if the scope of the original work changes drastically, we have the ability to end contracts. And as stewards of U.S. taxpayer money, we try to have rules in place to fund impactful efforts, and then stop funding if the project is not able to proceed as planned. And a really big plus here is that CIP awardees are offered technical assistance through the series of DOE laboratories that work on distributed wind, including NREL, Sandia National Laboratories, Pacific Northwest National Laboratories, Lawrence Berkeley Labs, and others to help the companies achieve intended goals. And we'll talk more about that tomorrow. So just some examples of continuous technology innovation. Bergey's done more than this, and we need to add another block. But a good example of utilizing CIP to its fullest. Bergey came in 2012. It's like, let's do a system optimization and reduce the cost of our, workhorse of Bergey Wind Power, the 10 kilowatt XL10. But around that time, the industry was having a hard time. Solar costs really plummeted, and the competition to be a distributed energy resource was tighter than ever. So in 2013, Bergey completely redesigned their turbine to be the XL15. No more furling, longer blades, increased double the energy output of the turbine without increasing the cost that much, and achieving a cost of energy of about half of what it was, down to somewhere in the 13 cents per kilowatt hour range. And as you can see up top, the Lazard market report from a couple years ago had rooftop solar at about 15 cents a kilowatt hour. So, bringing it down to the competitive cost of energy. Further technology development involved development of new power electronics in partnership with Intergrid and a brand new inverter that has continued to go through testing, listing, and further evolution. And then using a CIP in 2015 to get this turbine certified. Of course, it's always the end goal. If you're going to make it to the market and you want to be eligible for incentive programs, you have to go through the certification process. And then for innovation and further cost reduction, there was a foundation using no concrete for faster installation, a new application for the XL15, proof of concept for a deployable system. And then really harkening back to the core of CIP, which started out with primarily component innovation thrust, focusing just on the alternator, using CIP funds to optimize their permanent magnet alternator. And then in 2022, they used our brand new topic area of commercialization and market development to develop a financing program, lowering the barriers to costs. And then we need one more block out here for 2024, where Berge Wind Power was awarded a manufacturing process innovation award to improve their blade manufacturing process, lower the cost, and keep up with the growing demand. So yeah, thanks to many of our serial CIP applicants for demonstrating the various ways to do it. Of course, it's hard to beat this one as an example. Over the years, we've added topic areas based on industry feedback of what do you need funding to do. So it's evolved to 10 different topic areas that you can submit a proposal for. This includes prototype design development or manufacturing, installation, and testing of a prototype. So sort of prototype development all the way through testing, or component innovation, such as we saw with the alternator, or system optimization, where you want to optimize several systems in the wind turbine. Small wind turbine certification and or electrical safety listing is under this topic area, or for larger turbines type certification and listing. We had inverter listing embedded in these, but it's such a big barrier to market entry for distributed wind right now. We pulled it out last round as its own dedicated, topic area for inverter listings. And of course, manufacturing process innovation, and then product commercialization and market development. So 2021 is when we added prototype manufacturing. Folks needed money to build the prototype. In 2022, added commercializations. Like, way took us all the way to certification. Now we need funds to sort of get into the market with this optimized certified tech. And then inverter listing was added in 2024. We'll go through these in the next session in more detail. So previous projects within scope include prototype designs, overall system optimization, looking at how to optimize a combination of components in the system, improvement of specific components, inverters, blades, towers to reduce cost, any kind of turbine under 1,000 kilowatts of rated power, micro, small, mid-size, horizontal axis, vertical axis, or even unconventional cross-flow or other configurations within, the realm of electricity producing wind turbines up to a megawatt. Testing, lots of testing involved in CIP awards, including prototype testing with a plans toward getting to certification, small turbine certification, component listing, and global type certification. And then, of course, manufacturing process upgrades, where you have an existing process and you want to invest in tooling or processes to make it better. Outside the scope, well, technology that appears to be violating the laws of physics, such as maximum performance, um, maximum CIP greater than the Betz limit, uh, insufficient preliminary work to assess turbine viability or probability of success, so not developed enough. Turbines that don't consider basic wind dynamics, like wind changes direction or other, not addressing significant topics identified within the proposal, so just not addressing the merit criteria well in the proposal, or an incomplete proposal. It's we can't assess the readiness of a technology when all there is a website or a video or a brochure and nothing real. Um, a standalone component, you may have a great idea, but you have no way of articulating a partner or a target turbine manufacturer that will utilize your new product. These are all outside the scope. Turbines greater than 1,000 kWh, too big. Not a US based company, so we do have to subcontract with a US based company. It can be a global company that has a US based component of its affiliate or part of its company, but we do have to contract with the US based entity. More than one topic area included in the proposal. So, we may talk about this tomorrow a bit, but you can't say, I want to do component improvement, I also want to do prototype testing, I also want to do certification, and combine, chain together a series of topic areas into one proposal. Currently, the rules have been the proposal is for one topic area, or proposals that don't match the topic area being solicited. I mean, we have received proposals, but it looks like they were written for something else, and they're not really not specific to our CIP topic areas at all. Those are difficult to score well. And then I haven't seen too much of this, but it's okay to submit multiple proposals to do parallel efforts and more than one topic area, but not when you submit multiple proposals submitted to different topic areas that are really the same turbine and conflicting. And it's like, well, maybe we want to do this, maybe we want to do that. Just fund one, and there's no cohesion between the proposals, and that creates confusion with the scoring and does not work well with our scope. Changes in the scope, so they are flexible to a degree. Once you propose a project, we evaluate it, and then we make award decisions. And once you kick the project off, we know something's changed, and we can consider a shift in project focus from the intended proposed work. Maybe a different approach to improve a specific component. So there is some flexibility because we know things change as you move forward. Shifting between specific sub-tier vendors is okay. Project schedule changes, for changes in staffing or other unexpected challenges happen as well, and we can roll with it. But you can't really shift your effort across topic areas. So you may start a project in turbine certification and then say, we need to actually go back to prototype testing. That's too large of a departure from scope. Changing in a primary vendor, it has to be evaluated, but that could be impactful and may not be allowed. And then large changes in projects cost, you can renegotiate, but if it's a large change in cost, that may not be allowed. So some flexibility, but also we have an obligation to stay within scope as much as possible. Scoring criteria. So when the RFP goes out, there's very clear merit criteria and very detailed responses that should be included in the proposal, as well as the weighting of each category. So the RFP document should be your companion and template to submitting a proposal. But for example, the small turbine certification topic area we ran in 2024, we scored the technical readiness and provisions for the installation and long-term maintenance support of your wind turbine. So this wind turbine is designed, looks good, and there's a plan for getting it out there in the market and supporting it. And then, will it impact the U.S. market? Is this something that can be, and will be competitive and make an impact 20%? And then demonstrate that the wind turbine is ready for certification, or the component or system is ready for listing, and the offerer has presented a sound plan that will lead to certification in the U.S. market. Team, personnel, expertise. And then last year we added sort of an internal diversity, equity, inclusivity, and accessibility assessment, which was new for us. And we gave it a weighting of 15%, similar to the team. So look carefully at the merit criteria. You'll get fewer points if you don't directly address what's in the RFP merit criteria per topic area. We do have additional program factors that we use, totaling about 5% of the score as we try to achieve final selection. We check the diversity of manufacturers, geographic diversity, type of wind turbine system diversity, CIP topic diversity, turbine size and type, check price participation or cost share, and detailed plan for proposed technical support that may be needed from the lab. So these are all factors that just go into fine-tuning the overall scores. So, the only challenge here is, especially if you've submitted a proposal and it was not awarded, is that CIP is quite competitive. In 2024, we received 28 proposals requesting $5.9 million in funding. So 16 of those were graded up in the competitive range, meaning a 70 or higher, showing significant strengths according to the RFP requirements. But due to the limitations of the funding, we were able to award 13 projects in 2024. So that's less than half of the proposals received, but a good number of the proposals that did score well. So again, to develop a successful proposal, check the merit criteria. Demonstrate you have a concept that has a justified and clear path to certification and cost parity or competitive costs, so that it will make a market impact. Some recommendations: if you're making some incredible claims, you must provide strong evidence or risk losing credibility. So if something sounds incredible, then you should have technical background behind it. Technical expertise should be demonstrated with a team that covers all the bases. So, if a consultant still needs to be identified for a skill set, then identify in the proposal the skill sets that will be sought. But we look at the team, and we look at the understanding that you need this set of skills to successfully implement the proposed project. So you don't have to be a wind turbine manufacturer to apply for a component improvement award, but you do need to identify a specific turbine for which the product will be deployed and have a documented consultation with the manufacturer. So we just don't want to fund development of a product that is not going to be used. If it's applicable to multiple vendors, then you can articulate this, but you still need to identify some letters of support from the industry that your product is indeed something that could be utilized. And then we'll talk about this more later, but most of our CIP efforts do have an internal go, no-go decision fairly early on. So have a look at that carefully in the statement of work from when the RFP is released. We only guarantee funding through the go, no go design review just to provide us an off-ramp for turbines that, following a detailed design review, are deemed to not have a chance of impactful success. So I said before that really, even if you're back in the prototype stage, you need to think all the way to the certification finish line, as this is really needed to be successful in the market. Even if it's a great idea, if you can't articulate a path to certification and as a competitive product, then you may score low on readiness or impact on the market. Make sure you understand the appropriate standards that will be needed to get to that certification level, confident in your design, talk to certification bodies, and we'll talk about that later today. Other than some specific requirements, if you need to do something that's a little outside of the requirements of the RFP specific to your proposal, then you have to explain that in a way that the reviewers can understand why you're making a departure from the what's being asked for. Okay, so really, we're trying to have these efforts and taxpayer money be spent in the U.S. We realize that sometimes that is not possible, where a vendor or some efforts have to be performed outside the U.S. In that case, please provide justification why it is not possible to do it in the U.S. Still, it needs to be a U.S. company for the subcontract, but and then we do prefer efforts to be in the U.S., but if not, please justify why not. And if you list people on the team, then they should be actively working on the effort. So include letters of support articulating how these team members will contribute to the effort. Don't just list a bunch of names of people you know. Okay, so that's my overview of CIP. And are there any questions? So at right now, right on time, we're going to segue into an overview of the potential topic areas presented to you by a variety of NREL staff. So somehow we're right on time, I think.
As you transfer into that,
Yes.
a couple of quick things just to reinforce them. But as Brent says, CIP is very competitive. And so pulling together a proposal at the last minute and putting it in is not likely to be successful, because you will be working, your proposal will be graded against people who have been working for months on their proposal. So really think carefully about whether this is an approach for you. In previous years, we've been able to provide some kind of pre-proposal technical support through outside subcontractors. Heather Rhodes Reavers specifically, we're not able to do that this year, but there are a number of entities like Heather and others who have good experience in developing CIP proposals, and would certainly, if you're jumping into this for your first time, I would certainly encourage you to talk with us, but talk with some other people who have put in CIP proposals in the past to understand what requirements are there are to be successful. And then lastly, we've gone through all of the topics that were that have been released to topical areas, and we'll talk about them right now. There's a whole bunch of them. That does not mean that all of them will be part of a call for proposals. And we're looking for feedback from everybody at this point over the next little bit to determine if we should focus the topical areas in any way. In 2024, we did not provide any of the early stage, the prototypes, the prototype testing and things of that nature, because due to the market space, DOE was very interested in making sure that that we have commercial turbines on the market. So we focus primarily on the listing, the turbine certification work, as well as the commercialization. So just because we're going to go through all 9 of them, I think it's 9 if I'm remembering
10.
correctly, Brett, 10. That doesn't mean all 10 will be released, but your input on level of importance of those for your industry, for your company, would be very useful.
Yes, thank you, Ian. Perfect. All right, let's talk about these potential topic areas, all of them. So we have evolved into 10. It looks like 9 because here's 2. Prototype design development, prototype manufacturing installation, prototype installation testing, and then component innovation or system optimization, small turbine certification, inverter listing, type certification and listing, manufacturing process innovation, and product commercialization and market development. So that's 10 because we have 2 there. A reminder from Ian, these are all the topics that have evolved over the years. Topic areas could change and potential future round. So we are expressing views based on what we've done in the past in CIP, and haven't decided what to do with future CIP. So even though we do want your feedback because we are in the phase of life here of working on CIP 2025. So check when the RFP, if and when it comes out, check the specific RFP topic areas and language, what's available, and the funding levels, the cost share requirements carefully. Funding levels and cost share requirements are limits, not requirements. So design proposals appropriately. In other words, the effort does not always cost what the maximum funding level is. You have to justify the cost of the project and apply the cost share, but we have to have max award amounts. Okay, so we have 10. We have evolved into 10 topic areas, but as Ian said, as we designed last round 2024, we all decided to focus on products that need testing, certification, manufacturing improvement, and commercialization. So out of that set of topic areas, we ran 1, 2, 3, 4, 5, 6, a subset. So the lower TRL, where the prototype design needs development to the stage where it is ready to be a prototype, it was not offered, as well as prototype manufacturing that hasn't been built yet. But we ran these sort of trying to get the turbines to the end of the line of certification and commercialization as a focus of the funding that we had. Okay, so we're going to go through these one by one, and first we're going to welcome NREL CIP staff, David Snowberg. So thank you, Dave.
All right, thanks, Brent. Yeah, so our first topic area here to discuss is the prototype design development. This is the lowest technology readiness level topic area that we would have offered in the past through CIP. So the scope of this is on the detailed design and analysis and design of a beta prototype. And this could be for both either a turbine system or a major component of a turbine. And through that analysis and design, it should be focusing pretty comprehensively on the manufacturability, performance, cost, installation, your operating and maintenance plans, your supply chain, and all the components. So this is not the testing or the manufacturing of the prototype or the certification of it, although all that should be considered in the analysis and design of this prototype. But it is has the intent of at the end of this CIP to have a prototype that's prepared for to be built. This topic area has had a go no go early on in the process, where there's an opportunity for NREL and other lab staff and with DOE's input to provide feedback to make sure that this concept is on a path to be a successful prototype. And this can cover both conventional distributed wind designs as well as unconventional concepts. And this has had a max award amount in the past of $200,000 with a 20% minimum price participation from the awardee. I think that's all I have. Thanks, Brent.
Yeah, thank you, Dave. And you'll see a little examples, hyperlinks in the top right. So some of these on the NREL CIP website. At the bottom, there's an accordion of all the topic areas with a brief description. And there you'll find all the one-page project fact sheets per topic area that you can that will really help give you an idea of past funded projects. So, thank you, Dave. Next topic area is one of those three newest ones, and it's called. And I'll turn it over to Scott Dana from NREL for this one.
Can you hear me okay?
Yeah, I heard that.
Just had a server decide to spool up in here, so hopefully you're not getting too much background noise. But yeah, I'll talk about the prototype manufacture and install. So this is really the heart of this is really getting to a prototype ready product. So we're looking for a proposal that is going to outline where you're at in your process and how you are going to arrive at a fully designed and essentially test ready turbine. There's the installation component here as well, but it's not a strict requirement. It's more of an add-on because we recognize and understand the cost of installation can be pretty substantial. So within the award, we have a max. The ceiling is 400K, with 300,000 max going towards the manufacture and build and test ready product, and then with 100,000 ceiling for the installation. But there's a calculation there, so it's going to be scaled based on your peak power. And for the manufacturing side, that's going to be $3 per watt. So you will calculate your peak power of your turbine for that dollar value, and whichever is less is what we will be willing to fund under CIP. And then similarly for the installation component, we have a 20,000 starting entry point, and then a $1 per watt of peak power, and again whichever's less on the $100,000 ceiling for the installation portion. The price participation is a little higher here, so we're looking at 50%. I think here, and on the manufacturing, those are you're going to find the highest price participation entry. So there's a lot of hardware, a lot of hard costs that go into this type of work. So we're looking for some matching from any participant on this type of award. This was added not too long ago as we saw the maturity of CIP getting to the actual final product ready for testing. So we wanted to recognize that within the program and continue advancing these turbines and technologies. There's a few hyperlinks on this slide. I think these will be shared so you can learn a little bit more about a couple of past awardees on site and PACOs who have gone through this award.
Okay, thank you, Scott. And yeah, you reminded me just to say that we are recording this, and we'll post the recording for day 1, day 2 of the workshop on the CIP website. fairly quickly. And so you'll be able to either go back and look, or folks that were not able to attend can view the content asynchronously. But all the links to the example projects are on the CIP website. Thank you, Scott.
Yep.
All right, Scott's going to keep going with the next
I got the next
evolution.
one too. Yeah.
Yeah, the next one too.
Yeah. So kind of dovetailing into what we just talked about. This is another iteration of the process here in prototype installation and testing. So there's a little bit of overlap you might see between the last award type, and again here we're looking for a ready product that needs to be installed and or tested. So it's not strictly both. If you have a turbine that has been developed and maybe you've already installed it at your test site, this could be just for prototype testing. But if you also, we recognize if you have a turbine that is ready, has been built, you've kind of gone through the diligence of the rest of the steps that we've kind of gone through here. There is an installation funding portion in this contract as well. So here we're talking about a maximum of $250K. Again, there's kind of some of that scaling based on turbine size. So 100,000 would be the ceiling for installation. But based on your peak power, we would adjust that amount. And then there is a maximum for 150,000 for testing. So again, it doesn't have to be both. It doesn't have to be installation and testing. If you're ready to test, that would be taken into account in the review process. And if you're needing installation support, that can also be part of this award as well. And here we have a lower price participation at 20%. And again, we've got a few hyperlinks there for some examples in the past where we've supported this kind of work under this award. I think you're on mute.
Thank you, Scott. If you plug numbers in here, 80, if your turbine has a 80 kilowatt peak power or less, then the max award amount starts to go down for the ones that have this little calculation. And these are just elements of the effort that NREL saw as scaling somewhat with size. So that's why they're there. All right. Thank you again, Scott.
Yep.
Okay. Ian Baring-Gould from NREL is going to talk about both component innovation and system optimizations in these two slides here. Thank you, Ian.
All right, thanks, everybody. So two awards here that are fairly similar in a lot of ways. The component innovation and then the system optimization. So component innovation first, as you can see, a very popular topical area. We did not offer it in 2024, but have for all years previous to this. This is really focused on if you have a single component that you would like to improve, innovate around, and whether you're the turbine manufacturer that is interested in doing it or working with a specific turbine manufacturer, as Brent has alluded to in the past, to take an element and make it better. So you have a turbine that is working well. Maybe it's a certified turbine, and you want to extend the rotor on it. You want to put in more advanced power electronics. You want a taller tower, things of that nature. You want to look at the foundation. This is the opportunity to do that. Or if you have a turbine that isn't certified, you've got a turbine that isn't commercially available at this point in time, but with a larger rotor or something of that nature, then it could become more competitive. Certainly, this is a topic area that would work well for you. As we've said a number of times, it needs to be aligned with a specific turbine. So we are not interested in certifying a technology, or not certifying, and having you innovate a component that does not have a path to the market. And so you definitely have to have that path to a market. For component innovation, we are expecting that component certification costs would be included in the proposal. And the whole idea is, I have a turbine, I want to put new power electronics into it, and it's a certified turbine now, and I want at the end of this project to again be a certified turbine. And so thinking that certification is part of that development process. And obviously, to do that, you need to be very closely engaged with your certification body to make sure that the innovation that you're looking for can be implemented without the whole turbine needing to go through a recertification process. Now, if in the development here you can't do that, you don't think that you'll be able to do, if you do new blades and you'll have to go and recertify the whole turbine, that's not a showstopper. Just tell us that is your expectation, that you've talked to the certification agent, and you feel that you will need to do a full certification of the turbine, in which case apply for this, tell us that, and then potentially in the next round, you could apply for a certification project. Going back to Brent's initial comments, we would not want to see a component innovation and a request for certification at the same time, because it will take you a couple of years to innovate on the component. And we certainly would mean you're not ready for certification yet. Okay. An additional element here is we are also open. I have always been open to certify or to have you develop components that expand the market applicability of your turbine. So a tilt up option for the turbine that you already have, so that it can be deployed in remote communities on islands or something of that nature, integrating your system into a hybrid power system with solar and storage. So anything that would help your current product fit into additional market spaces is certainly applicable. And when you're looking at the cost structure of that, how this innovation that you want to implement either lowers the cost of your turbine or lowers the cost of the competition that your turbine is facing. Again, historically, $400,000 and a 20% price participation, that may or may not change. Lots of examples that we have here of companies and specific projects looking at innovation. Next slide. So the system optimization is just what it says. You're looking at a system that you have to optimize. So if you're looking at a turbine and your turbine and you want to innovate, and it's not just the blades, it's not just a new power converter. If it's something that is going to take a number of kind of assessment of a whole system, the whole drivetrain, the whole turbine in itself, but it's a number of different components that you're putting together to be able to lower costs, to improve performance, to increase reliability, whatever that is. You're looking at a system of elements, then this is the topic for you. And this is how it's different than the component innovation. The key element here is that it's expected that certification is not part of what you're trying to do here, because if you're changing a lot of components, you either don't have a certified product that you want to get cost competitive, or you have a certified product, but you're going to change so much of it that you are going to have to go into a certification element. And this does allow you to spend more money on the innovation process of your system, because we expect that you're going to need to do that. This could certainly lead to either certification as a next step, or potentially to component innovation if you've determined you do this optimization of your system and you determine that everything is pretty good, minor changes to everything except the alternator needs to be completely redesigned for your turbine to be cost effective. You do the optimization, you innovate over a component or two, and then you go into certification. or something along those lines. So we expect that you are going to design to certification because everybody should be designing to certification. But in a system optimization, the expectation is not that you come out of it with a certified product. And that's it.
Thank you, Ian. Very
Of
good.
course. Thank you, Brent.
Yep. I have nothing to add there. All right, next I'll do this one. Okay, so, well, I'll just say before coming to NREL, I worked with the Small Wind Certification Council, so I got into turbine certification for a while, starting back in 2009, and I'm really thankful that this has come about in our industry. And we'll talk about that more in the next session. But for this topic area, small wind certification and listing, this has evolved into a focus on turbines up to 150 kilowatts, which fall within the scope of the ANSI ACP 101-1 2021 standard developed a few years back. So for turbines under 150 kilowatts, this is the topic area for you to get your turbine certified to that U.S. national standard. The topic area says and listing, so you can also include work to list the turbine assembly or components to the applicable electrical safety standards or other U.S. standards as needed to meet the requirements of markets that you're targeting, such as listing the whole turbine system to UL 6142, which is mentioned in the National Electrical Code, or listing the generator to the appropriate UL code. And we'll have a session on electrical safety listing tomorrow. We'll hear from Joe Sposey from RE Innovations. So this maximum award amount here is $220,000. I'm sorry. Yeah, we've changed this one a bit, but the old award amount was $200,000 to get the turbine certified. An additional $80,000 to do some load measurements, but the WIA standard doesn't allow load measurement based load determination. So we have edited this topic area funding amount, but we do provide additional money for turbine listing. So as it is now, pardon my flipping, it's now maximum award $300,000, which includes $220 for the turbine and $80 for the listing effort, the optional listing effort. So I'll fix that slide. And as usual, the price participation for turbine certification and listing or listing, we've changed it to, is 20%. Okay, so again, we'll hear more about this later. The next topic area is inverter listing, and we'll hear about this from our Lee J. Fingers.
Hello, everyone. Can you hear me?
Yeah.
Okay. So this topic area is about inverter listing or power electronics. There's a long history in this industry of this being an Achilles heel of small turbine designs. It's a difficult thing to get right. This topic area is about taking an inverter that already exists and expanding it to be able to meet the needs and the requirements of evolving standards, such as 1741 SB, which is increasingly required in various states and localities for connection to the grid. The idea is to take a device that already exists and improve the programming, improve the hardware as necessary to meet the needs of the testing that is required to meet the standard, including doing in-house testing and so on. It's not designed to fund the development of a new product, but it is designed to help have an existing product follow the standards that are evolving, and therefore expand the market that is available to these small turbines. Maximum award amount is 200,000 with a price participation of 20%. We've got some examples up above of projects that we funded in the past for this purpose.
Great, thank you, Lee J. And you know, we did just add this topic area in round 2024. So, but inverter listing used to be embedded in the small turbine indoor listing topic area. So that's why these examples are, you know, predate the inverter listing topic area. But it was such an important need of the industry and a little confusing to be embedded into that topic area. We pulled it out into its own standalone topic area, fully focused on getting these inverters listed to the latest and enter these key markets. Thank you, Lee J. Okay, next is type certification and listing, and we'll hear from Jeroen Van Dam on this one.
Sure. So as Brent mentioned, he listed the other certification topic. This topic is for either turbines that do not fit in that ACP scope, right? So anything that's got a peak power over 150 kilowatts, then we would like you to pursue this IECRE type certification. We'll talk a little bit more about that in the next session. It's an international, a global certification. And then also, right, there is the option if you are fitting within the ACP, but you really think you want this global certification, right, then make your case on why that's important to you, and then you can go down this path, right? This is a more expensive path. That's why you also see the maximum award be quite a bit higher than in the category that Brent just described. Like that one, the inverter listing can be part of it. It doesn't have to be, but it can be part of it, right? It'd be good if at the end of this there's a product that you can seamlessly install in the US, right? That's really what we're after here. And then globally, right? Yeah, the type certification then applies more universally. There's two what are called operational documents listed there. If you go to the IECRE website, you can actually download that and you can see kind of what certification through IECRE really entails. And for those that have been in the industry for long enough, you will recognize a lot of that with the old IEC 61400-22. It's all kind of modeled off of that and evolved. That's everything I have on this one, Brent.
Great. And again, we'll hear a little bit more about type certification process in the next round. So thank you, Jeroen. Next session, I mean. Okay, Dave Snowberg's going to tell us about the MPI, Manufacturing Process Innovations topic area now.
Okay, yep, thanks, Brent. So with all these topic areas, I think it's important to every word in the topic area is key. So in this case, it's manufacturing. So it's focused on innovations to what manufacturing process you already are using and how that can be innovated to make improvements in terms of reliability of the product, of the manufacturing process, safety of it, as well as economics. So looking for ways to potentially reduce costs, improve the throughput of your manufacturing process. Lots of different ways improvements can be made. And it can focus on equipment, supply chain, quality control, automation, lots of different ways to make those types of improvements in your manufacturing. In this case, the maximum award amount in the past has been $500,000 with the 50% minimum price participation. Some of the background there being that equipment that you purchase for these innovations is something you would want to cover under your price participation, not from the CIP, so that the ownership of that is no question. It's yours. So that's it for this one, and thanks.
Thank you, Dave. And yeah, we haven't funded an MPI award for a few years, so it's good to get one out from round 2024 for Berge Wind Power's blade manufacturing. Very good. Thank you, Dave.
Yep.
Any more? Yep. Ruth is going to tell us about another newish topical area. So, Ruth, if you're here, take it away.
Yeah, thank you, Brent. I don't know why my camera is hazed over. But CMD is a topic area we added in the 2022 round in response to some industry feedback. We heard that you needed a little more help here to address a gap in the market development process. So we supplied this award, and it's targeted to help you with costs associated with commercialization, developing partnerships. If you have a new certified turbine or an existing product that you want to bring to new markets, then this is the topic area for you. The award amount is a maximum of $150,000, and the minimum price participation is 20%. You'll see in the upper right, Berge Wind Power and EOCycle were the 2022 awardee winners. And you can go to that NREL CIP website and read the fact sheets and learn more about those projects. But to give you an idea of what a project might look like in this category, Berge used their award to help create some new consumer financing options for their turbine product. And EOCycle used their award to develop an ag industry partnerships and a related marketing strategy. In the 2024 round, we had 3 CMD awards: EWT Americas, SEVA Powers America, and IES, or Intelligent Energy Systems. EWT is working to enhance their marketing efforts in some windy areas of the Midwest. SEVA wanted to focus their commercialization for their 250 kW turbine in 8 key states, so they're working on that. And IES is just getting launched to expand some distributed wind deployment in Alaskan communities with turbines up to 1 megawatt. And we should have some new fact sheets coming in the next few months. We'll post them on that website so you can learn more about those projects. I think that's it for this. Thanks, Brent.
Okay, thank you, Ruth. Ruth is not usually blurred out, but it was good to hear from you.
I don't know what's happening there.
Okay, so again, at the bottom of the CIP website, you can find even more project descriptions or project fact sheets than we had listed in there. And the round 2024 projects have just been kicking off, and their first deliverable is a project summary. And so the NREL communications team will be adding even more example projects to this part of our website, which I think really helps explore what types of projects are funded. So just a reminder that I'm happy to book some short half hour or maybe a little more meetings on Friday. I did this last year and it worked fine. It's just to ask some specific questions about your project, maybe like which topic area would it fit into best, and any other questions or feedback you may have. So if you want to meet on Friday, it's not the end. We're around for meetings after this, but I have blocked off Friday for a series of short meetings. Just give me an indication of what you want to meet about, and I'll send the team's invite. Okay, well, thank you very much for hearing about our topic areas. And so next at 2 o'clock, we are set to 2 o'clock Mountain Time. We were set to start off with an overview of turbine testing certification. So luckily we're a little ahead. So I would say it's a good time to take a 5-minute break. So at just 3:57, a little before 4 o'clock Eastern or 2 o'clock Mountain. Let's come on back and finish this last informative session of the day. So quick 4 or 5 minute break. We'll be right back. Thank you. Okay. All right. Thanks everyone for coming back. Yep, there's Sean. Hi, Sean. Let's see. What time did I say to come back? 57, 58? Well, I think I said 58. I don't remember. Okay, like Ian said, if you have questions, let us know. I'm pretty sure I just said, let me know if you have questions and then went right to break. But at the end of this session, we'll have time for questions. But again, the end of tomorrow, we'll have a good half an hour or so for some discussion and feedback on topic areas and funding levels and any other opportunities for improvements to CIP before we nail down the details of the next round. Okay, so we're going to get started with this session. We fund a few topic areas involving turbine testing and certification. You know, we also talked about electrical safety listing, and that we'll have an overview of tomorrow. But today we're going to focus on turbine testing and certification. And you're going to hear from me, Sean Martin from ICC SWCC, Jeroen Van Dam from NREL, and Dean Davis from Windward Engineering. Okay. You guys there? You got your people there? Hello? Hope so. It's hard to tell. So, for starters, let's talk about this relatively new ACP 101-1 standard. Why would you want to get your turbine certified? Well, you know, it still remains optional, I would say, but has been used for quite a while, since about 2010 or so. Turbine certification for small and medium turbines was established as a mandatory criteria for eligibility of incentive programs. Therefore, it became very important to access key markets with incentives to go through the formal certification process where a third party, independent certification body performs conformity assessment of a turbine design to the requirements and standards. So while it's optional, it will kind of shut you out of key markets, and you know, is probably evolving to the point where to the point where electrical safety listing is, where it's needed for building permits at all. But at the moment, primarily turbine certification, not electrical safety, but turbine certification is used for consumer protection. There's lots of variety of small turbines at various states of development and third-party evaluation on the market. So it really helps prevent unethical marketing and false claims by having a standardized certification process. Allows the turbine manufacturers to demonstrate that their turbine model meets the performance and durability and quality requirements of the standards. Allows for apples comparison between ratings for different size turbines. And then the funding agencies and utilities that are offering financial incentives have greater confidence that wind turbines installed with these public funds will have been tested for and evaluated per the standards. And so some, if not all, most incentive programs will only fund certified turbines. Has definitely been the trend. And over here is an example of a SWCC label showing some standardized ratings from the standards. And so for the topic area of small turbine certification, we now have this relatively new ACP 101 standard from American Clean Power Association. There is a companion article here from NREL that goes through the justification and the background of how we got to this standard and the updates from the previous AWEA 9.1 standard. But here's a summary of what's in there. First of all, it goes up to 150 kilowatts of peak power. So it used to go up to just 200 square meters, which is about 20 or 30 kilowatts these days, and folds in that 100 kilowatt range of turbines roughly, with a maximum peak power of 150. Like most national standards, it relies heavily on the technical details in the suite of IEC 61400 standards. So it sends you to the -12-1 standard, which has a small wind turbine annex to do a power performance test, makes some exceptions to optimize the process, such as the omitting the need for a site calibration. It sends you to -11 for an acoustics test, and also some minor exceptions there, such as the uncertainty calculation being optional. The duration test, it was seen as a pretty significant barrier to market entry and a high cost in the -2 standard, so it was greatly reduced to just operate your turbine in normal operation for 10 hours and 15 meters per second and above winds, and log up 1,000 hours of power production just to show it can operate normally over a range of wind speed conditions. Safety and function test requirements. Check the control and function and protection systems in the turbine and are laid out in the -2 standards. And here's where you see the instructions on how to receive an accurate peak power for your turbine. And the design part of the standard, the details for design methodologies are in the -2 standard. We pass through some exceptions to that standard where an assumed turbulence intensity at 15 meters per second should be 20% instead of 18. We limit the design classes to class 2 or S for special, limiting the simplified load methodology to 30 kilowatts, which is about 200 square meters, but really adding some caution that it's not recommended for turbines above about 10 kilowatts. And then we've added some model validation guidance and requirements based on turbine size categories, and defined a new category of wind turbine, micro wind turbines up to 1 kilowatt with limited requirements, and changed the reference annual energy rating from 5 to 6 meters per second annual average wind speed. There is an annex regarding certification or conformity assessment, and the standard adds a requirement to really keep an eye on certified turbines in the field, with field inspection requirements of 5 turbines in the field for 3 years, because it's really crucial to get that direct feedback of how the turbines are performing in the field, in case problems need to be addressed in the design. And that's now a provision of the surveillance, and in addition to the existing factory inspections that are performed by the certification body every 2 years. So the table at the back of the ANSI standard, the ACP standard, shows these sub requirements, these requirements by size category. So micro turbines are only required to get duration testing, power performance testing, and safety and function testing, and everyone receives a label. Whereas the 1 to 30 kilowatts shows that simplified load methodology is allowed, but not recommended greater than 10. And it provides some measurements for model validation, and which increase as turbines increase in size. So this is sort of a departure into setting up subcategories of sizes within a standard and varying the requirements throughout. So, the Pacific Northwest National Lab maintains a list of certified turbines. Currently, in the the 2024 market report as of June 2023, there were 7 on the list: the Berge XL10 and 15, the Everready Kestrel, the 25 kilowatt EOCycle high watt, the SD6, and the Skystream is back on there. So this is ever evolving and can be monitored, and we'll hear more about turbine certification on the list from SWCC next. So now let's hear from a certification body that does this for a business, Sean Martin from ICC SWCC. Take it away, Sean.
Thanks, Brent. It's a great pleasure to be here. Thanks, everyone. I'm assuming you're going to be my remote control here, Brent.
Yeah, look at that. I'm ready.
Yeah, I know. This is great. I can tell you what to do. All right, fantastic. All right, so just a quick word on the certification programs that we offer. We are an ISO 17065 accredited certification body. We are accredited to certify small and medium sized wind turbines. We make the delineation between those two size ranges at the cutoff to ACP 101. So anything under 150 kW peak power falls under the small category. Anything from 150 to 300 we classify as medium. Should note on the medium side, this is not an IECRE type certification we offer for this. This differs slightly from what was described by Jörn previously and will be discussed further. So that's another offering that we provide, but it's not IECRE. Just clear on that. Getting back to the small wind side, it's important when we're talking about certification to understand precisely what is inbounds and out of bounds. Let's be clear with this. This does not include electrical certification. We often refer to that as electrical listing. It's those terms can be used somewhat interchangeably, but so what we do focus on is safety and function assessments, standardized power performance, acoustic performance, and structural design and load testing. Now, you'll note the different arrows there, and that's meant to signify the fact that the different size ranges of turbines, as shown in the matrix that Brent just had on the screen, have different requirements. Not all are required to meet all of those. For example, the less than 1 kW or less, or the micro wind turbines, do not have to undergo acoustic performance testing, for example. So the specific requirements for a particular turbine are dependent on both the size and the specific configuration of that turbine. I should also note that this does exclude the tower and the foundation. That's a common question that we get. ACP, that's based on ACP 101-1, which does not include them. Electrical safety, you want to look at UL 6142, and I think there'll be some discussion of that coming up. That is not included, and it does not include anything regarding inverter listings. That's UL 1741 SASB. So that's just a quick note about what is inbounds and what is out of bounds. Brent, if you could just go to the next slide, please. Real quickly on the application process. The process has a couple of key steps. What we're going to look at here is one where for a turbine that has never been tested, which is often the case for certification, which is often the case for CIP awardees. We start with something that we call a preliminary review. You submit an application for a preliminary review, which contains key information on your turbine, where it's produced, and also a number of submittals, such as a test plan, and some details regarding the configuration and geometry of your system. We then conduct something called preliminary review, which involves a staff and review first, and then a review by our certification commission. We're looking for a couple of key things. Number one, We want to check to make sure you're in scope. We don't want to start down the road if we find out that your turbine is not in scope for ACP 101-1 for whatever reason. 2, we want to examine your test plan. We want to get confirmation that the proposed tests are appropriate for the turbine. If you get into ACP 101, you'll find that it is a fairly, I don't want to say flexible, but it is a wide-ranging one. It's not highly prescriptive. So the requirements for each turbine can vary somewhat significantly, as I mentioned, based on size and configuration. So we want to be sure that we agree between the certification body and the manufacturer and the test facility exactly what tests and structural analyses will be required for your specific turbine. Just because you have a turbine, let's say it's a 30 kW turbine, they might have different requirements for a hot versus a VOT and so on. So that's a critical stage. Next, we'll look at your proposed test site and overall test configuration, the tower you plan to mount on, the location, the Met tower, that kind of thing. We want to make sure that they'll meet the basic requirements. If that is successful, we would then approve the preliminary review and invite you to make a formal application for certification. If you proceed with submitting that application document, we then draft what we call a certification agreement. That document formalizes the conditions of certification that were reviewed in the preliminary review. It lays out the test site location, the specific tests, the specific analyses, the testing organization that you plan to work with. All of these steps, if it seems a little draconian at the front end, that's on purpose. We know that the testing is very expensive. We know that the testing is very time consuming. So we want to be absolutely sure that going into the testing for certification, that you and we are on the same page. We do not want you to do testing that would not be applicable or acceptable. I don't think we have, any of us have the luxury of wasting either the time or the effort with that. So then getting underway, once it's signed by both parties, you're free to begin testing. We do not do the testing. SWCC does not have a test facility. You select either the test lab or the testing partner that you choose to work with. There are a number on our website that you can look to, and we're open to others as well. If they're accredited, you can just go ahead and do it. There's only a few around, but you can just go ahead and do that and then send us the test report. If they are not accredited, meaning they're not accredited to ISO 17025 as a test facility accredited to do wind turbine testing, then we would need to do a site inspection so that we can confirm for ourselves that you've met the requirements. That should be done at the front end before you get too far down the road. That's why it has the dots around it. It's optional depending on whether what lab or provider you're working with. From there, you go ahead with the testing and any structural analyses that might be required. And when finished, you submit those documents to SWCC. We conduct an evaluation of those results and the turbine design against the requirements of the standard. And if successful, we award the certification. One or two other key things. If approved, that certification is valid for 1 year. It has to be renewed every year thereafter. So that's an important thing to do. One last thing about the preliminary review before we move off of that. It is not a design review. This is very important. We are not permitted as a certification body to give you feedback on your design. We are not permitted to answer questions on your design. We're not permitted to optimize your design. We only assess it. That would be a conflict of interest for us to do that. So I want to clarify that up front. Brent, can you flip the slide? So again, as I mentioned, we're confirming eligibility. We're vetting the testing organization. We're establishing an agreement that outlines the fees and the tests and so on and so forth. Why? Well, we want you to have no surprises. We want you to go into the testing process knowing what will be required. And that we will indeed accept the results from the specific site and test provider that you wish to work with. So it is a key step at the front end of the process. I should note that we do charge for preliminary reviews. The reason for that is there are organizations that go through the preliminary review and come out the other end and say, yeah, I don't think so. We don't want to do it. And there's a fair amount of time involved. It's not a complete review like we would do for a full certification, but it is a first pass over it. So we do charge for it. I will say too that NREL has graciously awarded a grant that covers the cost of preliminary reviews. Thank you very much. Wow, look at that. I read my mind. And those reviews can be covered under the NREL grant in many cases. So if you are interested in a preliminary review for your turbine, I would recommend that you reach out to us, and then we can see if it is eligible for the funding to cover the cost. And this includes a little bit more information on the kind of information we would be getting at the front end. People always ask how long it takes. It tends to be a bit of an iterative process. We get information from you. We often ask questions. We dive into the test plan, at least. So there's a bit of back and forth. So it really comes down to how quickly we can get all the information we need from. Next slide. Okay, one last thing. I did at the very beginning mention that the process I described was for a situation where a turbine had not been tested. There are other situations that can apply. So that would be A in the diagram below. There are other situations. For example, you may have existing test reports or existing certifications from other organizations internationally. We may be able to work with that. That's case B. So in some cases, the preliminary review in that case would involve a review of your existing test reports to see if any or all can be used to satisfy the requirements of ACP 101. It's impossible to say. It will depend on the specific circumstances, the age of the test reports, the conditions, whether or not the design has changed. And then there's also the case of an update from an existing OEA 9.1 certification. We are not requiring existing certification holders with OEA 9.1 to update to ACP 101. However, it is an option available to them. So if somebody with an OEA 9.1 certification wishes to update, we then would do a review to determine if any additional testing or analyses would be necessary for their specific circumstance, and then provide the details to them. So there are several points of entry, and we're happy to work with you in whatever capacity makes sense for these. I also say that we commonly get requests at the beginning of the CIP process for letters of support for a CIP application. If that is something you are looking for, if you're seeking that for certification, I would recommend that you reach out to us sooner rather than later, early in your application development process, and we'll be happy to work with you in whatever way is appropriate. With that, I don't know, Brent, should I call for questions, or should we just hold that to the end?
Any questions for Sean?
Annual certification. Yeah, I see there's a question. What's needed for annual recertification? That's a great question. Shall I address that now, Brent, or would you? I don't want to eat up your extra time here.
Go for it.
Okay, fantastic. Yeah, so as Brent mentioned, there are requirements in the ACP 101 standard regarding the certification. So there are annually, what would happen is you would apply for renewal. We would request information from the turbine, specifically whether there have been significant changes to the manufacturing process. We'd be looking for information on whether the design has changed, things of that sort, and we would review that. As Brent noted, ACP 101 does require that we obtain information on 5 units in the field for 3 years, so we would be following their progress via reports submitted annually on those. So I don't want to call it a probationary period, but for 3 years we would be looking for that. And then separately, we would do factory inspections. Factory inspections, the first one is done within 6 months of the award of the first certification. And every 2 years after that, that 2-year interval is specified in the standard. We do have, and we do that on site. So we send an inspector to your production facility to examine your quality management system and production control. Whole point of that is to make sure that you can reliably produce a turbine that matches the performance and function of the one that you submitted for. That's the whole objective. So a couple of different pieces there, and we can certainly go into more detail if you have further questions later, but hopefully that helps.
Thank you, Sean, and thank you, Niles, for that question. Yeah, the certification bodies per ISO 17065 are obligated to perform surveillance of certified products of any kind to make sure they maintain the validity. So it's all part of that. Thank you. All right, Sean, thanks a lot for that. And
My
next,
pleasure.
hear from Jeroen Van Dam of NREL on type certification. We also fund projects to help folks achieve this.
Sure. Next slide, please, Brent. So as mentioned just before, right, IECRE, it's a system, conformity assessment system that lives in IEC. And so it's an international certification system using international standards. It relies on a series what are called operational documents, ODs, which basically lay out exactly what you need to do to obtain the type certification. Those documents are publicly available. If you go to the IECRE webpage there, you should be able to find them. If you cannot find them, let us know and we can send you the link or we can email them to you. You'll see a lot of similarities with what used to be the IEC 61400-22, which kind of described all the different steps that it entails. Most of those steps are still in place. There's 2 documents that apply to the CIP. It's either 501, which applies to any turbine, and just like the -1 applies to any turbine, right? Any size turbine can use that standard. There are many type certificates mainly for the utility scale turbines listed on the IECRE webpage. So if you want to look at all the certificates ever issued by IECRE, there's a large database there, and you'll see that all the major OEMs these days use IECRE. Of course, we only fund things up to 1 megawatt. So 501 would apply to that 500 to the 200 square meters above, and up to 1 megawatt, you'll end up in 501. For smaller turbines, we have a separate version of what 501 does. It's the 554-1. Currently, no issued certificates there. There's one that we think will be posting a provisional type certificate in the next month or so. And then there's at least 2 others that are working towards their IECRE type certification. And we funded Java to pursue that through CIP last year. So it's a little bit different from how SWCC versus IECRE, right? It is the global, it is for really kind of global acceptance, so more than just the US. Oftentimes what you'll find is that that type certificate then gets complemented with national requirements around electrical code and or building codes. And that's how it is for large turbines as well. Next slide, please. The crux here is that you will be limited to the certification bodies you can use and the test laboratories you can use. And it's a little different than what Sean mentioned, right? So there are 11 CBs in the system, and those are on the next slide. These are both the RECBs, which are renewable energy certification bodies, and RETLs, which are renewable energy test laboratories. Those are test laboratories that have undergone a peer assessment. So they get audited, not just with right, an independent auditor from, say, an A2LA, but these are other test laboratories or other certification bodies that are going in and scrutinizing how other test laboratories or certification bodies are applying the standard. So this results in a lot more scrutiny because they know exactly where the pain points are. The other thing that's happening is that all these test labs are doing inter-laboratory comparisons under IECRE. So we're all these test laboratories, all 31, are participating together in these exercises, making sure that the level of conformity among them is kind of equal. That then leads to the mutual recognition aspect. And so here you can basically assemble parts and pieces from different vendors, and other CBs have to accept conformity statements from other CBs. And the same thing, right? If an RECB sees a test report with an ICRE logo in it, that means it has to be accepted for that certification if it's for the right turbine. So mutual recognition here is a key part of ICRE. You can basically assemble parts and pieces, but also once you have the certificate issued to yourself, it now has to be accepted by all the member bodies in ICRE. Test labs, there are 31 in the system. In the US, DNV and ArcVera, now part of Bureau Veritas, are two of those for field testing. WindTest also has an office in Iowa, and I'm sure there are other RETLs that can also kind of offer these services in the US, or you can do your testing overseas if need be. Next slide kind of lists all the certification bodies, Brent. And so here you'll see that there are no certification bodies in the US part of IECRE. So you would have to work with one of these. However, this list is pretty much everybody that's doing wind turbine certification kind of on utility scale turbines. I mean, there's only a few missing that work on just small turbines here, but all the major players here are on board. That's everything I had on ICRE.
Thank you, Jeroen. Okay, well, if there's a question, you can put it in the chat, but I think it's time for us to segue right into Dean Davis. Well, always look forward to presentation on turbine testing from Dean. So I'll let Dean Davis from Windward Engineering take it away. Thank you.
Okay, thanks, Brent. So just to start off, I probably have way too many slides and not enough time. So I'll go kind of quick. But anyway, I'm Dean Davis with Windward Engineering. I'm going to really address this kind of field testing aspect. So prototype testing, small wind certification testing, and type certification. I think we've already gone through some of these numbers, but this gives you an idea of what CIP is offering. Next slide. So again, Jeroen was kind of discussing a little bit of this, so I'll get through this quick. But in a nutshell, like for certification testing, in terms of the field testing aspect, typically we're going to have 4 tests. We're going to have power performance, safety and function, duration, and acoustic. I put an asterisk on the acoustic because under ACP, if you're less than a kilowatt, you can bypass that one. For type certification, it's a little different: power performance, safety and function, mechanical loads, blade structural, and then again, optional on the acoustics. Next slide.
Dean, your audio just got weird. No. Maybe turn something off, turn it back on.
Is this any better?
Yeah.
Okay. Oh, I hope that
Thank you.
holds. So anyway, so yeah, a lot of these tests are, well, these tests are all based on standards. Many of them, this IEC 61400 family of standards. So -2 for small turbines, -1 for larger. Power performance is -12, acoustics -11. And then of course we have the ACP, which is going to kind of supplement or work with these standards. And then obviously if you get into others, mechanical loads, there's another standard, and it goes on and on. Next slide. So I apologize for people that do have test facilities and I don't have them on this map. You can reach out to me so that if I do this next year, I can add you. But the ones that I know of are Windward Engineering. That's the one that I'm at in Utah. NREL does their own testing in Colorado. We have WindTest in Iowa. The one in New York, that's Joe Sposi with Intertech. I don't believe they're doing anything these days. Appalachian State, Brent was involved in that early on. And then Renew Test and UL in Texas. Next slide. Oh, I should mention too that the standard does allow you to self-test. So you could test wherever your facility is if you've got a decent wind resource. So ideal test site attributes, if you're kind of questioning whether you could test at your site, I say regular and non-seasonal winds. Obviously you can work with, you know, a test site that doesn't have that, but that's ideal. It'd be nice to not put up your turbine and have to wait for a wind season. Favorable zoning and permitting laws, obviously you don't want to get caught up in that. And then I found just my test site, I am located near hardware stores and lots of rental areas where I can get equipment and stuff, and that can be handy. For power performance, unobstructed ground, the standard kind of wants you to have minimum obstructions or obstacles around, as well as nearby turbines. Flat terrain is good. If you've got too much variation in your terrain, you need to either do a site calibration or take an exception on the standard. And then you will need occasional high winds. You really want to see the power curve up through peak power and beyond. Acoustics, quiet site makes sense. Unidirectional winds would be ideal only because the microphone has to be downwind of the turbine. So if it's coming from different directions, you're going to have to move your microphone around a little bit. No nearby reflective surfaces. And then unchanging ground cover. This is an issue that I have in the wintertime where I have snow or no snow. Some other places in the spring might have grass or no grass, and it could change things a little bit. Duration tests here, where really the bulk of it is we're just trying to get lots of power producing winds. So that usually doesn't mean extreme winds or high winds necessarily, just winds where we're producing. Doesn't necessarily need to be extreme. I said here some variability in the ambient temperature. That's not a requirement of the standard. I just think it's good if you're, if you're in a hot climate or a cold climate, it's, you might find out the turbine operates differently or components fail due to those ambient conditions. For mechanical loads, you do want the occasional high winds. You do want times of calm to do your calibrations, your in situ calibrations, and the standard wants variability and turbulence. Next slide. I said here the ideal site might not exist, or your site might not be the ideal, but you can really mitigate all those factors. And my site, I mitigate a lot of those. So next slide. Next slide, power performance. So getting into this, again, this would be an image of like an almost ideal site, assuming they had a wind resource, where basically you have no nearby turbines, you have no obstacles. You'd basically, in this situation, wind direction from almost every wind sector would be fine, other than the one where the turbine's in front of the anemometer type of thing. Other sites will be some, won't be like this. There'll be something different. Go ahead and click it, Grant. Or this is my site. I've got lots of nearby turbines. I've got a railroad cut on one side. I got a highway and a bridge. I've got all kinds of issues. I got buildings and shipping containers and stuff on site. But again, you can kind of mitigate it. In the past, we've done site calibrations as a way of mitigating it. ACP seems to believe, especially in the smaller wind turbine world, where there's not a lot of distance between the anemometer and the turbine, we can kind of forego the site calibration. Next slide. For power performance, typically you're going to have a Met tower upwind of your turbine, where you're going to have your primary anemometer, secondary anemometer, wind direction, air pressure, and air temperature. Next slide. Down on the ground, for me, it's in an instrumentation shed. You actually don't need a shed, but it could be a shed, could be a trailer, it could be lots of different things. But that's typically where you're going to have connection to the grid. So that's where your power transducer will go. And then as well as your data acquisition system. So that I'm showing this as the LabVIEW system that has a chassis and modules. And then for LabVIEW, I go into a PC, but again, you could have a data logger down there. Next slide. Power performance, it's likely that you're going to have a little bit more than what I showed there, such as RPM, maybe turbine status, pitch angle if it's variable pitch, wetness, humidity, or possibilities, rotor azimuth, etc. It kind of depends on your turbine, what your certification body would like to see. And to be honest, if you have it for power performance, then you have it for safety and function, you have it for duration, you have it for all the tests. And I estimate this is fairly high quality instrumentation typically that we're going to use for these tests. So I estimate about $30,000 if you didn't have any of this equipment, if you needed to go out and get your anemometers and your DAC system and that kind of stuff. Next slide. Again, this is pretty high quality instrumentation. Typically, it's going to come with a calibration sheet that goes through the calibration, gives you the constants to enter into your data logger. Sometimes instrumentation won't come with it, so you may have to get your instrumentation and then send it out to a calibration lab and get your calibrations. Next slide. So what's required? How much data do you actually need? Here I've broken it up into, this is all from -12, IEC -12, where you've either in the Annex H for small wind turbines, so that's 200 square meters or less, or the generic is above 200 square meters. But you're basically going to need, on the small wind turbine side, you're going to go 1 meter per second below cut in to 14 meters per second. And you're going to have ½ meter per second bins. And within each bin, you're going to need 10 minutes of 1 minute average data points. And you're going to need a total data set that's 60 hours. If you're above the 200 square meters, now you want 30 minutes in each bin, same 0.5 meter per second bin. Now 1 meter per second below cut in to 1.5 times the wind speed at 85% of rated power. So you kind of calculate that and come up with this wind speed at may end up being higher than 14 meters per second. And again, you want 3 times the data, so 180 hours. Next slide. So how long does it take? I'd say that the 2 factors on power performance, in my opinion, are how much data do you have to throw away because it's in an excluded zone. So if you've got a site like mine where the wind's got to come from very few directions where we don't exclude it, then we end up throwing away low data. Our site's fairly unidirectional, so it's not too big a deal. And then you could end up waiting around, depending on what wind season you're in. Obviously, you do need to see what happens at the higher power levels. So you do need to capture those higher winds. So you could be waiting around a little bit for that. NREL suggests 3 to 6 months. It can be. It's always, for me, it's always been in parallel with duration tests. So it's not on the critical path. It's like the power performance just kind of happens while you're doing duration tests. Next slide. In terms of the report, the standard, the -12 gives you really, it outlines exactly what needs to be in this report. It's really nice in that regard. These standards are actually, there's a lot of information in them and it's good information. So that's usually not an issue. If you go on the web, NREL has past reports that it's done that are posted there. That's a great template. Also, just download one of their reports and say, you know what, use this as a template. Typically, I'm thinking about 50 pages where half of that's kind of the meat of the report and the other half is appendices like calibration sheets and uncertainty analysis and that kind of stuff. Next slide. Acoustic testing, next slide. Go ahead.
Before we get into that, I don't know specifically what Todd Hammonds wants to know information on, but he says, do you have a recommendation for a manufacturer for all the necessary equipment? And I'm sure that's a long answer. And I didn't know if you had anything in here on suppliers of some of this equipment, but
I don't, but I guess I would say, again, if you go to the web, and actually my website has past reports as well. But if you get an NREL report, it'll show what instrumentation they use, what anemometers are used, what wind direction vane they used. So that's, and to be honest, that's pretty much what I've always done. I've just copied what NREL does, which obviously they're kind of the gold standard. If that's what they're using, then it's good. So I would recommend that.
Okay, good. Thank you, Dean. Thanks, Todd.
Next slide.
All right. Yep.
Acoustic, good news is, assuming you've and the power performance is kind of the, I set my equipment up around the power performance. It's the most restrictive one. And there's really no reason to say, oh, well, Duration doesn't care about some things, so we can, if you're already set up for power performance, you're kind of set up for duration. And that's kind of the case for acoustics. If you're set up for power performance, you're set up pretty well for acoustics. The other good thing is this test is, in terms of data collection, is fairly short. Bad news is data collection can have its challenges. There's just, the challenge I have is being next to a busy highway. That's the main issue. I've heard, I think NREL struggle with birds and planes and people talking and stuff like that. So those can be the other challenges. The data processing is much, much more difficult, in my opinion, than the processing for power performance or duration or safety and function. And it does require some new equipment that if you're just doing power performance, well, now you need to go get a microphone, a calibrator, some software, and another data acquisition system. Next slide. So what are the data requirements? Again, if we're less than 100 kilowatts, so cut into 11 meters per second. It does say in the standard, if you've got a turbine that controls power via furling or via fluttering or something like that, makes sense. That's probably a different acoustic signature than normal operation, so they'd like you to capture that as well. The measurements are just 10 seconds each in length. And then we're now in 1 meter per second bin width. So you can see it's not a lot of data, and we want 12 measurements or 120 seconds with the turbine operating and 12 measurements with background, so the turbine parked. Again, it's not a lot of data, and typically for me, it's maybe a week of collecting data, but it's obviously going to vary. Next slide. Some of the challenges, again, the microphone needs to be downwind. If your wind direction is shifting around a bit, that can be a challenge. Measurement chain needs to be calibrated before and after every measurement. For me, that means I'm here late at night, typically. You want background noise to be the same as measured. The way I've dealt with that is to set up either via the controller of the turbine or a separate controller where I basically run the turbine for half an hour and then park the turbine for half an hour, and then run for half an hour and park for half an hour. And within that, I'm kind of making the assumption, I mean, obviously, I think the terrain is going to change across an hour period. The wind speed obviously can change in that period, but hopefully it's somewhat consistent. And I can get, both background and operational in the same environment. And then, as I mentioned before, the quiet is the challenge part, I think. I mean, for me, it comes down to highway and crickets. Those are my big factors, but other people have other factors. And when I'm out here in the middle of the night and it's quiet and everything, it's amazing how many things, it's like, I've never heard that before. I've never heard that before. That I can actually hear the trucks a mile up the canyon, and the little picture is a little vent on a nearby building that, I've never noticed, but when I'm doing an acoustic test, it's like it's fluttering in the wind, it makes noise. So I go out and tape it before I do a test. Next slide. For the post-processing, again, this is a little challenging. So you'll need some software that basically goes from the recordings to numbers. And I've gone from that point, I've gone into Excel and built my own Excel spreadsheet. I think NREL at least initially did it the same way within Excel. They were using some macros and that kind of stuff. So it's all doable. Within Excel, people might, if they're very comfortable with Python or something, they might get into a little bit fancier way of processing the data, but there's a fair amount of processing going on. The standard, it's, you just step through it. They give you the equations, there's all the information there. So it's laid out, it's complicated, but it's well laid out. We have had sometimes, we were doing some round robins one time, and the standard seemed like it was saying one thing, and the certification body was thinking another way, and NREL was thinking another way, and we had to kind of go round and round. So the wording can be a little bit tricky at times. And then I think the other challenge is this: most of us aren't acoustic engineers, so it's a little bit odd, and we don't have a good intuition on what that means or why we're doing that, or why do you divide by 6 dB or something like that. I say here, data analysis absolutely needs to be validated. I can't imagine if you took a data set and went through the standard and came up with your results, that an engineer sitting next to you wouldn't go through it and come up with a different answer. So I think you need to validate and figure out, have some kind of validation process if you're going to do it. And then tonality is laborious and requires lots of manual clipping, at least the way I was doing it in the past. But forward one, click, print. But ACP is getting us out of that. So that's nice. Next slide. Duration tests. So again, the purpose here is structural integrity, material and performance degradation, quality of environmental protection, and then dynamic behavior. So what I've got here is from the IEC standard, I've kind of listed out everything, and then where I've strike through, that's what ACP is saying. Oh, let's not worry about that. Kind of making the duration test probably more fitting better to the value, the amount of effort required type of thing. So dynamic behavior is not required under ACP. 6 months of operation is not required under ACP. It used to be 2,500 hours of power production. Now that's 1,000. And then probably most critical, because I think some people are waiting around as much as a year and a half to fill some of these high winds. Now we just need 10 hours greater than 15 meters per second. If you have a major failure, restart the test, or fix the failure and then restart the test. And then IEC wanted this operational time fraction and analysis of power degradation, but ACP does not require that. Next slide.
Dean, real quick, Josh Grollo from Pecos says, did you say you do acoustic testing at night?
I do, yeah.
And then
But
do you have
because
do you know the DBA?
Because of the traffic.
Right. And then what's your background noise level do you typically have there, like in sound pressure, dB?
I don't remember. Although you can go to my website and you can download a report and it would be in there.
Yeah.
I
Windward
don't
Engineering.
remember.
Okay.
Yeah, it's been a while.
Got it. Thank you. All right, I'll go to the next slide.
Okay.
Safety and function.
Yeah. So safety review of OEM procedures and other manuals, review of personal safety topics, warning, safety labels, climbing related safety. So that kind of stuff. Just a general feeling about the safety would be how you'd look at that. And then the function is a bigger part of this, where it's like, and I say here, it's similar to commissioning procedure, but we're going to collect some data. So to me, I do safety and function after I've got all my instrumentation in place. And then we're going to basically, during high winds, we're going to have a grid fault, or, force a grid fault. We're just disconnected. We may pull a sensor out in high winds. We might look for extreme winds and just do a manual stop or a manual restart or something like that. So you're really just kind of poking on it. And to be honest, I tend to like, through the duration test, I'm collecting data as well. So I'm also potentially capturing some kind of weird condition, weird fault condition or weird wind condition. And if I find that, I usually search through all the duration test data and look for anything. I look for extreme turbulence events, extreme wind events, times when the turbine shuts down or restarts in rapid succession or something like that. So I'm looking for weird events. And then I put those in the safety and function as well to make sure that it looks like the turbine handles those conditions appropriately and as expected. And then within that, we're going to demonstrate peak power, power limitation, and rotor speed limitation, which I'll touch on a little more. Next slide. So here we got, and this one we'll just click through, Brent, but this would be for peak power. Obviously, you get your power curve, you find your peak power, and then you look at 95% of peak power, you find that wind speed. And then now we're going to basically, we're going to make sure that we've got 10 minutes in each half a meter per second band. That's 5 meters per second above this wind speed and 5 meters per second below this wind speed. And whatever power is the highest within those bins, that's going to come out as our peak power. Next slide. For max rotor speed, Here we got 2 hours of winds between 10 and 20 meters per second. Go ahead and click. And then we want to have 30 minutes that's above 15 meters per second and 30 minutes below 15 meters per second. And then within that amount of data, we're going to find our maximum rotor speed. And then the standard talks about interpolating or extrapolating that out to VREF. So it kind of depends on what small wind turbine class you're certifying around. Next slide. So mechanical loads. Typically, it's not required for a small wind certification. I'd say unless, and I guess this would be up to the certification body, unless we need some model validation for something that's non-traditional, non-hot. It is necessary for large wind turbines. It's a significant undertaking, I think. If you don't need to do it, I mean, you might do a little bit of it, but I think to really get into it, it's going to take a lot of money and a lot of resources. In terms of instrumentation, typically you're going to have tower moments, rotor moments, blade moments. To get these loads off of the rotating rotor, you're going to want slip rings or telemetry. And then to make sense of all that in the post-processing, you're going to need rotor azimuth, yaw angle, stuff like that. So it can balloon. And anyone that's done mechanical loads testing, if they thought it was simple to start with, probably don't feel that way towards the end. Next slide. The standard is the IEC 61400-13. They talk about the minimum required channels. They have a recommendation for additional channels. They want to see transient load cases, braking, high wind, grid loss, startup. They want normal operation. They have a capture matrix within that standard for number of data sets per wind speed, range of wind speed required, turbulence variability in the wind speeds. They talk a bit about how to do the calibrations and then how to do the data processing and reporting. So it's all kind of captured in that -13. Again, it's a decent lift if you want to really get into it. Next slide. I think that's all I have. Yep. So.
Great, thank you, Dean. Yeah, thank you very much for going through that efficiently. Any further questions for Dean on testing? I do think I blew through your first slide here. I think Heather said thanks for the cost info. See if this stuff is still pertinent. Oh, I'll get there.
That's what I saw. That's what I saw for last year.
Mm-hmm. What? Oh, these award amounts. Gotcha. I see. I got it.
Yeah.
Okay. So we've reached the end of our day. We've got a few minutes left for questions. Let me just pull up the agenda so we can see what we're expecting for tomorrow. Tomorrow we'll just get right back to it and get an overview of turbine component inverter listing from Joe Sposey, and then talk about design reviews from Dave Snowberg, procurement and contracting details from Kendall. Scott, Dana, and I will go through some additional miscellaneous items, and then we should have a good half an hour or so to run some things past you and also solicit input on any ideas on improving, changing CIP. So that's what to expect for tomorrow. In our last 5 minutes, I just want to open it up for any questions or comments you might have. I think you can just unmute yourself and say something or put something in the chat with our last few minutes here before we take off. I appreciate everyone's attention today, and also a thank you to the speakers for covering these details. All right, I think we all covered it pretty well today. So we will
There's a
convene
question from
again.
Robert. Robert,
Oh,
you want to
you gotta,
unmute yourself? No?
he's waving.
Oh,
Like, all
okay.
right, bye, bye.
Bye.
Heather wants me to post this again, our LinkedIn group. So I think if I just put this in the chat, you can join. I think I have to approve it, but I'll figure that out. Request. I do have a request to join, so I will approve. Mike Berge. Welcome. Okay, any other requests besides the LinkedIn group? Great. Well, thanks again to everyone for attending. And thanks for all the speakers. We'll see you tomorrow, same time.